side divided by your short side. What kind of numbers do you guys get? 1.66 repeating?
Yeah.
What else we get? 1.5. What else we getting?
1.7.
1.7. What else we getting? 1.6. Anything else? What'd you get, Amber?
Oh, it ended up being 1.5. Yeah.
1.5 as well?
Yeah.
Excellent. Now, the reason, I should probably turn the camera. So the reason I had to do that was to see, this is something to think about. When you graph something in the standard viewing window in your TI, the window goes -10 to 10, -10 to 10. Now, if that's true, what shape should that window have? Shouldn't it be a square? -10 to 10 is 20 units wide, -10 to 10 is 20 units high. It should be a square. Why did they put a non-square rectangular screen on your TI?
Mess with us.
Well, maybe. But I think, let's come back to that question too. Driver's license. Anybody measure their driver's license? What kind of ratios did we get? 3.25 over 2, which is just about 1.6-ish. 1.61 maybe, 1.62?
Yeah.
Yeah. A credit card would be similarly. You ever notice that a credit card and driver's license fit in the same spot in your wallet?
Yeah.
Right? Yeah, they do. So credit cards, driver's licenses, little cards they give you to store those cards and things like that. The little punch things at Jamba Juice. They're always about the same dimensions. Now, one could argue that they're all the same dimensions because they make wallets that size. But then that's chicken egg. Why do they make wallets that size? Because driver's licenses are that dimensions, right? It's a chicken egg thing, right? It's chicken egg. Okay, good. Okay. Tiffany, cover your book.
It was 1.7.
Why the hell would so many of these pictures, I know in this digital age that we have, in this digital age, it's hard to remember pictures, like when you actually printed pictures and put them in on the wall. But what are some of the more common dimensions of pictures? Do you remember?
3 by 5.
3 by 5?
4 by 6.
3 by 5.
2 by 3.
4 by 6. 2 by 3.
8 by 10.
8 by 10. Let's just get those on. You guys are so fast now. That's good. If you look at some of the dimensions of these guys and divide the long by the short, 5 divided by 3 is actually the same as that. It's 1.67. It's exactly the same numbers if you think about it. 4 by 6 is, that's 1.5, isn't it? All I'm doing is dividing the long by the short in each of these cases, yes? 2 by 3 is 1 1/3. That's 1.3, a little bit low. And 8 by 10 is going to be a little bit low too. That's going to be 1.25. Oh, I said 1.5, I wrote 1.3. I'm sorry. Do what I say, not what I write. So, what you notice here is, why would so many things be close to the same number? I would predict if you actually averaged all of these, which we then could do, typically we just average them all because they all have the same weight, they're one measurement we each took. But I would predict that if you averaged them all, they're going to come damn close to this number over here. So why? Well, I don't have a good answer for you. Oh, Amy, go
I was
ahead.
going to say maybe it's just cheaper to stick with like machines that cut out the same size.
But why do they cut that size? That's my question.
Oh.
See, I love what you're saying. I think that's the wallet analogy, right? Once you have a wallet that fits a driver's license, then let's make the club card be that size. Let's make the library card be that size.
Credit card companies.
Let's make the credit card be that size, or whatever card came first.
Right.
But my question then is, why that size? Why wasn't a credit card shaped like this? Or a square?
Right?
Or square.
But a square would fit in your pocket too if we made the wallet the right size, right? This is my question. I mean, I don't have a good answer.
In the 60s, they had square photos. Do you remember that with the white around the edges?
Yes. Well, there was also the Polaroid, which took that and made the bottom you could hold it right on. That's right, they were square.
Yeah.
And what happened to them? They're
That one,
gone now.
The Polaroids aren't exactly square.
Well, the picture itself is, right, but the frame is not. Yeah, but that got retired like the dinosaurs, didn't it? Which is funny, because if you go into
They do
Picasa
have
now,
them
they
now.
actually have a Polaroid maker. You can make your picture into a Polaroid with the crop.
They have actual Polaroids.
But it never works, because your damn picture that your cell phone takes, what's the resolution on an iPhone picture? Hang on, I don't know this. Let's just do, no, we'll do iPhone. iPhone picture dimensions. There we go. Standard image style. Let's take a look at this.
Or not.
It's like 1024 by, look at this a lot, because remember that sunrise I told you about on Sunday? I took a picture of it on the phone, and I got it home like, sweet, I'm gonna blow it. Oh no, I'm not. Because it's only 1 meg.
Yeah.
I'm like, crap, it's 1 meg. Why didn't I have my big camera with me? Because I wasn't planning on shooting a sunrise. I was planning on catching trout. Okay, it's loading. I think it's loading. Is it loading?
It's trying to.
It's trying to. Come on, COCC, you got this. Come on, baby. Looks like you haven't started
Try a
Firefox in a
different
while. You want to clean it up for a fresh look? You know what? The hell with this. Get my phone. Just look at the damn thing. Probably tells me, right?
Maybe.
Maybe. Let's see. Photos. There's me fishing in the river. Sure doesn't tell me. Cubby. No, it doesn't tell me.
I think if you go to like details.
Oh, thank you. Details?
I think if you go to like
Can I do that on the phone?
Details, property, options, something like that.
This is advanced for me. See, that's rectangular.
Yeah, it shows on your screen.
That's an Instagram picture. That's square, because I Instagrammed it.
Oh,
But
yeah.
that, screw you, website. Hang on. All right, it's a picture of Max pointing at a rainbow. Okay, you guys ready? I'm gonna throw some numbers at you. I'm gonna need you to do the division. Now, screw you, website. I'm doing this myself. Okay, you guys ready?
So that's aspect ratios.
2 and 9/16. So 2 plus 9 divided by 16. Just that. Get that number. 2 plus 9 divided by 16. Divide by. Well, that's almost exactly 2. No, it's not. It's 1 and 14/16. So 1 and 7/8. So whatever I said first, divided by 1 plus 7 divided by 8.
14 what, 16 you said?
Yeah.
It was a 9/16?
First one was 9/60s, right? 2 and 9/16. And then just under 2 is like 1 and some change. Yeah, this is good. What's that come out to be, friends?
3.43, is that right?
It's going to be 1 point something, yes?
1.4 is what I
1.4, so it's actually falling in these. But look. As the resolutions change, they begin to hover as they get more. 16 by 9 is like the widescreen format, I believe is what they call widescreen. 16 by 9, which is a square of 4 by 3. Look at these numbers. They're beginning to creep up to that aspect ratio of about 1.6. Again, it's getting close to that golden number. Why? I don't have a good answer, Josh.
I have a question.
Yes.
How come it exceeds the...
Oh, because that's not an exact, it's an approximate. That is an exact mathematical value. But what our eyes perceive as okay,
I was gonna say it's visually appealing.
and that is the best argument I've heard over and over again, is for some reason a rectangle that is in these dimensions looks right to us, visually appealing to us. The boards in this room look too skinny, they look too short and too wide, because they're not in that ratio. These lights look cool and modern, because they're really skinny and really long. Like you wouldn't say like, those are cute lights, those are modern, they're very severe lights, right? Right? This board, this screen might look okay. It looks more okay than these lights. But that's kind of a gut feeling, right?
Yeah.
But what's fun about this is, and what Christina is talking about, what Josh was mentioning earlier, it's everywhere. So what I began to do research into was, okay, where is everywhere? And the second question is, what can we check in class together? Which is why you all have, additionally, rulers. So I looked at some places where the golden ratio is supposed to be. 1, allegedly, if you measure your belly button to your feet, and then if you measure your belly button to your head, and you divide long by short, you should get the golden ratio. That seems a little too PG for me to be doing in class. So, what I'm going to do is something else I checked. We mentioned in class last time, if you measure successive phalange bones,
Oh, yeah.
right? That's too hard to measure. I've tried that. It's too hard because there's too much skin in the way. So I found a biological place on the body, a physiological place on the body. I think we can measure G-rated and probably get some good numbers on. And it's